Thank you everyone for joining us today. We have Anthony from Kaggle and Chintan from Uber joining us for a fireside chat on how models fail. Anthony, you want to kick off an introduction about yourself?
Sure. I'm Anthony Goldbloom, co-founder and CEO of Kaggle. So for those of you who don't know us, we are a very large data science and machine learning community with somewhere over a bit over 5 million users. We started off running machine learning competitions, and now we have broadened out to also have a managed notebook service, as well as a place where people could share their execute and share Jupyter notebooks, as well as a public data platform where people can share data sets with each other. And as of 2017, we still run under our own brand and as our own team, but we are under Google, or acquired by Google.
Awesome. Super excited to have you today. And Chintan, do you want to do an introduction on yourself?
Yeah, absolutely. Thanks for having me. So my name is Chintan Turakhia. I'm a part of Uber in the engineering group, and I lead several teams within the rides marketplace, and been enjoying the ride at Uber, and we are using lots of data to build great algorithms to help our riders, drivers, and the marketplace become more efficient. And seeing how these models go from idea to concept at the scale that Uber is doing is pretty incredible, and also challenging at the same time. So excited to have this chat with everyone here.
Awesome. Super excited to have both of you all. So, one of the core topics that comes up a lot in conversations with organizations and ML leaders is bringing that model from the research environment into production is really difficult. And there's a lot of moments where models fail when they actually, translate or go from research to production. Anthony, you founded this super awesome community at Kaggle where lots of folks build these models, compete with one another, share them via notebooks. How companies use these models and put out competitions. How do these models that people build on Kaggle actually translate to production? Are there a lot of successful stories, or do you hear any insights about going from Kaggle to production?
Yeah, for sure. So maybe to explain machine learning competitions as an introduction to this topic, we have companies post data sets and problems. So they'll typically post training data and test data, and people compete to build the most accurate algorithm. And then at the end of a competition, the winning team wins prize money, or actually typically the top 3 or the top 5 win prize money, and in exchange for the prize money, they give the winning algorithm over to the company that hosted the competition. So the first thing that comes out of a Kaggle competition is you get a sense for, given the signal in the data set, or you get a sense for how accurate you can physically possibly get for a given data set, and given this state-of-the-art in machine learning. Because what happens is you have many people, they can see how they're performing on a live leaderboard, sort of pushing each other to do better than they would if they were working in isolation. And so that's the first thing about a Kaggle competition. And so sometimes we do have customers for whom the winning model is not accurate enough, and that is still a useful learning because they know what is possible, they know what they have today or what they need, and it may be the case that either the winning model is not a large enough lift above what they already have, or it's not accurate enough to be worth productionizing. In the cases where a model is accurate enough to productionize, there's a bunch of challenges. One is that, first of all, the code that has been written by the data scientists very often like kind of hacky code, right? It's just like it's experimental code. It is not aimed at being productionized. A second issue is productionizing getting the features into production. Maybe it uses external data sets. Sometimes we have customers who allow people to bring in outside data sets, but then you need a production flow of that data in order to get the model into production. A third challenge, which is maybe a little bit more Kaggle specific, is often the winning teams will ensemble many models together. And so the best single model might perform with 80% accuracy, and an ensemble performs with 81, because a competition is incentivizing people to squeeze everything out of the model. What we try and do is at the end of the competition, there'll be a write-up documentation as well as handing over the code. And we encourage the winners to strip back the model to maybe the version with a single model and fewer features that they found along the way that was almost as accurate, and that we do in order to try and help productionize models. But this is a hard handoff in Kaggle land, to go from the data scientist to the machine learning engineer who productionizes the model. But the sense I get is it's not that much easier inside companies, and I feel like Chintan might have an interesting perspective on what that handoff is like inside a company.
Yeah, I was just about to ask. I mean, Chintan, you're like on the other end of productionalizing and operationalizing models at high scale. What do you think are the challenges that you've seen sometimes models struggle go from research to production? Why do you think that is? What's hard about that?
Yeah, so I think Anthony described really, really nicely kind of when you think about building models for accuracy, and that's the incentive, how people get that done. But when it also comes to productionizing models, the incentive is not just accuracy, it's making a model that works at scale and that's reliable. So reliability and the ability to move that model into your production environment is an incentive. The challenge though, the handoff from like a data scientist to an ML engineer, backend engineer, I think there's several reasons why those handoffs can be challenging. I think one of them is data scientists and ML engineers typically have sort of a different ramp up on their experience and their tech stack, right? Where ML engineers and backend engineers are more focused on the systems and the scale and the reliability, whereas data scientists are typically looking at the algorithm side of things and the data sets themselves. And there's a spectrum of knowledge there across these different types of roles. So the more that these different functional roles can communicate with each other and work with each other, the easier those handoffs become. So we got to have everyone speaking the same language, both figuratively and literally, right? Taking something from a Python or Jupyter notebook and then translating that to your production language. You may not have all the same functions, the operators, you may not even have the same handling of types, right? And so things can get lost in translation. So at the core, being able to land on a common language and framework is important. I think the second challenge in getting research ideas into production is when you're building models that represent the world, well, the world varies, right? It's physical, it's changing, it's dynamic, and data in itself then can be lossy. You may have missing data, you may have incorrect data, different pieces of data are being logged in different services and may have different join keys. And so you may have misalignments in time. You don't necessarily get a clean data set to operate off of at the beginning of your journey. And so when you start your research, you get that data set, but when you push to production, the data in production may not represent necessarily sort of how you began your journey in building the model.
Got it. And you talked about this handoff kind of between maybe the data scientist and an engineer. I mean, what do you think the future will look like? Do you think the future will be a full stack data scientist? Do you think there will always be that handoff between the researcher and the engineer who ends up actually putting it into production?
Yeah, I mean, I think that the future, it's not clear, right? I think there's always going to be an important role for data scientists to play in the industry, especially on developing new algorithms and pushing the boundaries on what's possible. And I think there's always going to be an important role for engineers to play in the industry, which is realizing at scale highly reliable algorithms, models, and systems. I think the future is a world where the sandbox is shared, right? Where you can have, look, it takes multiple people to make things real, right? And for those people to share the sandbox, the tooling, the language, the framework, right? That I think is important to get different people across the spectrum of skill sets to be working together to productionize the models. So I do think a future where tooling is not siloed and can be shared, and tooling that operates both effectively in an offline world as well as an online production system, and where the gap between the two is as small as possible, will lead to a good outcome of these handoffs.
And Anthony, I guess, you know, do you agree with that? I mean, do you feel like a part of Kaggle is also to kind of the language that data scientists are using, having more engineers kind of learn that language, be that sandbox or tool that they share? Or do you think that, you know, data scientists are going to do their own thing and engineers are going to do their own thing, and you know, there's more of the data scientists have to learn how to become engineers?
Yeah, I think there's probably a combination of things are going to happen. I think that probably similar to a direction Chintan was going, the tooling is going to get better. This is something, you know, I have my Kaggle hat, but I also work work at Google, and this is something that Google Cloud Platform is putting a lot of emphasis on, making it much easier for the data scientists working in a Jupyter notebook to create things, to have their code be easy to productionize. My suspicion is that probably for a good number of use cases, the data scientists themselves will be able to use tools like the tools that Google Cloud Platform or others are building in order to productionize models. But I think when you get to, you know, whether it be Uber scale or, you know, very large company scale, that is where you're going to need, you know, that's where the machine learning engineer role still becomes crucial, because the challenge, you know, for models that aren't, you know, crazily high QPS requirements, probably, you know, a lot of the challenge is getting a model that is accurate enough that, and it just needs to perform sufficiently well. When you have these very large scale models, the challenge is you have a very difficult challenge both on training a model that's useful and then being able to productionize something that as much resembles that model as possible in a in a very high performance way. So that's probably the place where the machine learning engineering role is going to remain crucial.
Got it. And do you feel like data scientists, you know, just from your experiences, do you think they think about how this model is going to look like in production today? Does that come up in conversations that, you know, maybe on Kaggle communities or as they're building their models? Chintan, do you see that in teams that you've worked on? Do data scientists kind of at the building of, you know, at the model building phase, think about how this is going to look like in production? Should they be doing more of that?
I think several years ago, I think that would have been less the case, where people building models are thinking less about production. But I think it's really shifted, and I think it's shifted for a few reasons. One, the impact of a model can only be realized in production, and that's super important. And as engineers, engineering teams and data science teams partner and work much more closely together, the path to production becomes top of mind for everyone. That becomes part of the conversation and part of the planning and scoping of the project. And I think now that that is part of the narrative, I think everyone is thinking, hey, how do I make a great model? And how do I get it into production?
Yep.
I would say we are not seeing that shift so much on Kaggle, and the reason is that, you know, as Chintan was saying, if you want to have an impact on Uber, you have to build a model that is production ready. There is nothing in this is a limitation of Kaggle. There is nothing that really incentivizes somebody to care about you know, how productionizable their model is. And it's interesting. I think that you know, Kaggle often gets criticized. You know, Kaggle is not machine learning is like a common trope, but there are some ways in which I think that is not, you know, not a fair thing to say. I think the thing that Kaggle trains people to do is iterate very quickly. Like, you throw a Kaggle grandmaster a new data set and they are going to iterate through ideas extremely quickly and give you a very good prototype model very quickly. But the thing we are absolutely not training people to do, and this is a very fair criticism of Kaggle, is we're not training people to think about how that model is going to have to need to be productionized. So yeah, frankly, I think it's a weakness in the experience we currently provide, or the training we currently give, I should say.
Yeah, and that is an important call out, where training training as early on as in the journey for anyone going into modeling. Path to production should be a core part of that training, and that's important to help make that shift.
Yep. What, like, I guess, what, where do you feel like models miss the mark in production? Like a big part of, this kind of, I say the next 10 years is going to be operationalizing models. And, insights that we're learning from even the first, set of organizations that are actually have models in production, actually starting to operate them at high scale. What are common ways that models miss that mark in production? Maybe Chintan, you can take this one.
Yeah, so I think places where models that have gone into production miss the mark. I think that the first one that becomes very blatant and obvious is offline training suggested, 80% performance, like 80% accuracy. When we put it online into production, you only get like 40, 50%. Like, oh, wait a minute, something's wrong here. So you go back, you look at the data, you look at the features. Is there a mismatch? Are we missing data, nulls, etc.? And you get back to the basics, right? Are my assumptions that were put in the model that was developed offline, do they hold true for the online production data?
Yep.
But beyond that, right, that's generally the first obstacle. But beyond that, models, I've seen a pattern where models can either overgeneralize or haven't generalized enough. And there's a couple of ways to slice this. One is, I think if you think at least in Uber's case, we operate in many, many cities. How do these models perform on a per city basis, right? Do they operate really well in dense cities? Do they operate not as well in cities that are having fewer trips because the data is more, the data sparse? How do we think about model sharding strategies? Because a one-size-fits-all model can be challenging, right? You need tremendous amount of data, tremendous amount of compute, and tremendous amount of training to generalize across such a large number of cities. But there's a path there. And so how do you start troubleshooting these models and defining the success criteria by the groups or cohorts of cities? In this example, for maybe a different company, it's cohorts of customers. How does the model actually perform across your entire population? Maybe it's working great for one part of your population, but you can't see that because the data is not segmented in that way. So I think it beyond just accuracy, it's where does the model perform well and where does it need to be improved against a cohort of your actual data?
Yeah. Is that troubleshooting, what Chintan's talking about in production? Are there parallels to that in the pre-production environment, the model building environment that you think about, Anthony?
Yeah, I mean, the one trap that people who are new to Kaggle, so maybe to give you a little bit more background on competition mechanics and then talk about what sort of troubleshooting people do. Competition mechanics, we give people a training data set and then we evaluate them on a test set data set, and they can see as the competition is going how they're performing on a live leaderboard. But then in order to generate a final score, we throw away that test data set and we retest them on a second test data set they've never had any feedback on. And what's more is, whereas they can put in up to 5 models a day on the public leaderboard, they can only select 2 models that get scored on that second test data set, which becomes a private leaderboard. And a very common pattern that we see for people who are new to Kaggle is they'll be competing, they're doing really well on the public leaderboard. Then we switch over, they make their 2 selections, model selections, we switch over and they drop 200 places. And what has happened is they have overfit to the score on the public leaderboard, and they haven't had good cross-validation. And it's amazing how often it's the case that somebody who has a really good, a good academic record, they have a really great industry job, and nonetheless, they're still getting hit by this problem. And the reason Kaggle catches people on this is because when you're working often in a company environment, you're not actually locked, like the data isn't locked away, the test data isn't locked away from you. And so we teach people, I said before, one of the weaknesses of Kaggle is that we don't train data scientists necessarily to think about how it is to productionize their model. One of our biggest strengths is we teach people the very valuable lesson of overfitting. And so the really good modelers on Kaggle have very, very robust cross-validation approaches, and they will almost not pay very much attention. Like they will think of the public leaderboard as another kind of set way they can get some cross-validation done on their data as opposed to the gold standard. And so that is a very common thing that Kaggle data scientists will do. The other thing is also, of course, depending on the type of model, looking at feature importance plots and things like that to just make sure the model isn't doing something nutty. I remember preparing for an early Kaggle competition. I got the data set from the customer. It was to predict prostate cancer surgery from, I don't know, let's say 300 survey variables. I was amazed at how well my model was doing. And I looked at my variable importance plot, and had prostate cancer surgery was the top performing feature. And of course, that very well predicts whether or not you are going to have prostate cancer. So, just doing sensible checks like that, hopefully a data set that we put out doesn't have, a feature like that. But yeah.
I guess, Chintan, do you feel like the troubleshooting flows that people are doing, that data scientists do in the pre-production environment, is the same of what you're seeing in production, or is it kind of completely different approaches to troubleshooting and digging into model, like really digging into model performance, not just an aggregate number, but certain cohorts and slicing and dicing to look at model performance?
Yeah, I mean, I think it varies, right? But there are certain patterns that emerge. So if a person who's building a model is only looking at a fraction of the available data, perhaps they're focused on a particular customer segment or even a particular city, then that individual would troubleshoot for that particular city or customer segment, right? But then when it comes to, you put that model in production and you scale it out to the larger, basically either cities or customers, whatever it might be, you'll see more problems, right? And so the troubleshooting flows are really, people are going to find what works for them, right?
Yeah.
And it's sort of a conflict where you'll forge your own path, find out what works for you, grab the tools necessary to get the job done. So, but that has to align with the incentive. Is the incentive to make a model that works very well, that only works well on a small portion of the segment? Or is incentive to make a model that is better than a heuristic, get it in production, and then improve it in production?
Yeah.
And, if, as a simple example, with those two different types of incentives, you'll see different troubleshooting flows. So I do think the incentive, the end goal, really makes a difference on how you approach troubleshooting as well. And that in itself will grow the knowledge base and experience of how people troubleshoot too. Yep.
Well, thank you both so much for joining today. Honestly, I feel like there's a lot of insights that I gleaned from just thinking about how someone from one end of the spectrum, considers kind of how models can fail, and then you're from completely other end of kind of operational at scale. And there's a lot of parallels in kind of, in parallels in kind of both ends, but still real success metric, comes down to, do we want to optimize in the research world? Do we want to actually get them into production? And like you said, the end goal really kind of decides how we want to troubleshoot and really understand how models work.
My read on this conversation is my half creates the problem and Chintan's half creates the solutions, or has to clean up the mess.
You're welcome.
Well, thank you so much. Any last words from either of you before we wrap up here?
This was a pleasure. Super happy to just talk about the subject and hear the different perspectives.
Yeah.
Yep. Likewise.